Thanks so much, Sophia, for introducing us to this community, and we're very happy to present and share some of our work. Today we'll be presenting our work around human AI complementarity for the goal of Amplified Oversight, presented by Sophie and I. This was work done by our team here, which we called the Raiders' team, the 6 of us here, including many advisors and collaborators and some past contributors. Sophie and I led the later writing of this work and completion, and we'll be presenting today. So first, to frame the problem of what we're trying to solve with this work, called Scalable Oversight, or we call Amplified Oversight, which is really about how as AI improves, the tasks it's going to be doing are going to be very complex, and evaluating those tasks are going to be very hard. It's going to achieve AI might achieve superhuman performance on tasks like summarizing hundreds of pages, peer reviewing a paper, or finding all the bugs in code. We rely on RLHF, or appropriate human evaluation of these outputs, to give feedback to the model, to train them, to make sure they're safe and aligned to human values. We need to be able to know if an output is safe to be able to train it to be safe. If we just rely on humans alone, they can be noisy and incorrect. These sort of tasks that AI can already do are very hard. And when humans are trying to judge if AI does this safely, they can easily make mistakes. But also, humans might be rewarding what looks good to them rather than what is actually good. And this is well represented in this concept studied partly by Anthropic called sycophancy, where they found that models are, when trained on human data, are actually trying sometimes create responses that are more likely for the users to agree with rather than actually correct. And so what we really want is like good oversight signal on like what is correct or not, or what is safe or not. And this is sort of the problem of amplified oversight. So where this blue line shows like as AI gets better, human abilities by default would not get better. And you could imagine like as AI gets better, you could just use the AI to give oversight on itself. And in fact, AI raters are already surpassing many non-expert human raters on several tasks. But what we show in this work is that humans currently still have complementary strengths to add. And by combining their complementary strengths, we can create a team that outperforms AI alone. And more to come on the future of AI raters later. But with this work, we propose that the solution here is really human-AI complementarity. So where we try to design rating protocols that create human-AI teams involving both of them to create a stronger signal than either alone, where we leverage the increasing AI capabilities in blue here and also the complementary strengths of humans to achieve better supervision. And also, this has the added benefit of maintaining humans in the loop and meaningful human oversight to ensure humans' values are represented. And in this work, we explore 2 approaches that have been studied in isolation. We explore them together, one called rater assistance, which is AI assistance for human raters, and also another hybridization, which is combining human and AI labels together, which we'll describe more in detail. And these 2 approaches are really HCI approaches, and fundamentally this problem of complementarity is an HCI problem, which we quickly realized in our work. And a lot of this work was investigating using HCI methodologies.
So here's the overview for our talk. We'll give a bit deeper explanation of what we mean by rater assistance and hybridization. We'll also share some lessons from the HCI literature that we found particularly informative for our research and that we think could be useful for any researchers thinking about human oversight and amplified or scalable oversight in general. We'll also discuss how hybridization may actually be key to enabling impactful assistance. We'll show some ongoing research that we've been doing combining these 2 approaches, and we'll end with a discussion of the future of human oversight. And we'll be really interested to hear all of your thoughts here on this work and what the future might hold. So what are rater assistance and hybridization? These may be terms that some of you are familiar with, but just to make sure we're all on the same page, when we're talking about rater assistance, we're thinking about how you could use AI to improve human judgment. So you can imagine a human rater or annotator doing a task of evaluating AI outputs, and then they could do that on their own, or they could do that with the help of an AI assistant. Maybe that AI assistant can point out flaws in the model's outputs or automate part of the rating task, making it easier for the human rater to complete. And there's already promising results in this space showing that AI assistants can help raters make higher quality judgments. And by hybridization, we mean a method for optimally combining human labels and AI labels. And there are different methods for aggregating or ensembling these labels. So you could do maybe a weighted average of human and AI labels based on some prediction about which might be better on a given task, or even route tasks to an AI rater or to a human rater, dependent on predicted ability. And there's also some initial work showing that this approach is promising for increasing oversight signal for training and evaluation. So as Rishub mentioned, these approaches are fundamentally human-computer interaction problems, and luckily the field of HCI has a rich body of literature that we can learn from and leverage. So there's been extensive work related to rater assistance, what the HCI field refers to as AI-assisted decision-making. And a recent large-scale review of the literature has interestingly revealed that human AI complementarity is hard to achieve. So looking across a vast number of studies, they find more instances of AI helping humans improve, but not helping the human AI team get above also the level of the AI. And so you kind of see that there's some augmentation abilities, but really kind of finding that sweet spot where the human AI team is better than the human alone or the AI alone is a really challenging problem. And the ability to achieve complementarity depends on many factors. So it can depend on the relative abilities of the humans and the AIs on a task. And this review reveals that it actually seems to be easier to achieve when the AI alone it performs worse than humans alone. It depends on the nature of the task. So it seems easier to achieve for kind of content generation or creative tasks rather than decision-making tasks. And it also depends on the division of labor, where it's easier to achieve if you have the AI complete subtasks of the rating task rather than doing the entire task in full. Two major obstacles for achieving human AI complementarity are over-reliance and under-reliance. Over-reliance is when humans kind of over-depend on AI output that might be unhelpful or incorrect, and under-reliance being the opposite, where humans might be resistant to help from an AI that is kind of genuinely helpful. And work has tried to explore what kind of information the AI could provide that might better calibrate humans' reliance in that information. And so things like providing an explanation for its judgments or a confidence in its judgments kind of a priori seem reasonable as ways to kind of better calibrate appropriate trust, but they actually don't always help. Interestingly, explanations can actually worsen over-reliance, perhaps by making the AI seem kind of more competent than it is or more confident in its answer. Finding that explanations can make over-reliance worse, researchers have also explored contrasting explanations, which do seem to reduce over-reliance, but frustratingly can also increase under-reliance, showing that there's kind of more work that's needed in this space. And lastly, there are many more lessons in this space, but another lesson that we found really helpful to think about is that the ease of processing AI information is crucial. So if you have a human rater doing a task and you give them an AI assistant, if that output is cognitively taxing to process and to understand, humans might just ignore and they might not get value from it. And so kind of thinking about how you present the information is critical. There's also been research on hybridization, what the HCI field refers to as delegation. There's comparatively less research on this approach, but there are initial promising results. Specifically, a delegation system based on AI confidence, where the AI makes a decision on its own if it's confident, or kind of delegates the decision to the human rater if it's less confident on an image classification task, leads to complementary performance, even when the AI outperforms humans alone. Interestingly, though, if you only rely on human confidence to do the delegation, it doesn't lead to complementarity. So again, we found this literature really informative and inspiring, and you'll see that it connects to a lot of the ongoing research that we're doing. We've kind of looked at these two techniques in isolation, but it's interesting to think what might happen if you combine them. And actually, there are reasons to think that hybridization may be key to enabling impactful assistance. We saw in the HCI literature that it's harder to achieve complementarity via AI assistance when the AI alone outperforms humans alone. And what we're doing when we are applying hybridization, we're trying to identify slices of data where the AI rater struggles. So again, as in this diagram shows, that maybe when it's lower in confidence, it might delegate those responses to the human. And it's possible that on these slices where the AI rater is struggling, humans could outperform AI. And if so, it should be easier for assistance to lead to complementarity on those slices. But even if humans kind of alone aren't better than AI on these slices, it's possible that the AI has biases or weaknesses that human strengths could counteract, such that the assisted humans on this slice could be even better. So we thought that it would be really interesting and also important to explore rater assistance in the context of hybridization. And that's what we did in our ongoing research. We had an internal text-based human rating task that involved making judgments supported by evidence on a realistic evaluation set. And we trained an LLM to do the same task as humans were tasked with. And so this AI rater could kind of do the whole task and provide a rating, but also that output could potentially be useful assistance to humans. So we had two steps here. First, we did confidence-based hybridization, where we routed tasks to humans below an AI confidence threshold and to AI above that threshold. We'll note that for confidence-based hybridization to work, you need a well-calibrated confidence metric. And luckily, and somewhat surprisingly to us, our AI rater was well calibrated. So its confidence did predict its accuracy on the task. We then explored AI assistance specifically on the human set. So we had humans complete the task on this human set on their own without assistance, or with assistance, which again was the output from this AI rater. And we tested different forms of assistance to see which form would be most helpful. So our first result is looking at confidence-based hybridization. So along the y-axis is accuracy, and we're looking at accuracy on the entire evaluation set. Please ignore the green curve for now and just focus on the horizontal lines. So on top in blue, we see the AI accuracy alone on the task, and below in orange, the human accuracy. So if we just look at AI performance and human performance on this task, the AI is doing much better. So you might think, okay, I should just use the AI then and kind of do away with my human raters. But if we do confidence-based hybridization, and one note here, the AI ratings are a label that is the majority judgment of 50 samples. So we sample the AI rater 50 times, we have 50 judgments, and we take the majority judgment. And the human label is the majority of 3 to 5 human ratings. So we see that the AI alone outperforms humans alone, but what if we do confidence-based hybridization? So along the x-axis now, you can see different confidence thresholds. And we calculated confidence by looking at these 50 samples of the AI and calculating the agreement across these samples with the majority judgment. And so if you pick kind of any one point on this curve, it means that kind of below that confidence threshold, all those examples were rated by humans, and above the AI. And we can see that there's a range of confidences where the hybridized accuracy is higher than the AI or human alone. So hybridization here is enabling complementarity. So even though the AI overall outperforms humans, there's a slice of data where humans are better. And Rishub will talk about that next.
Here we have confidence-based hybridization, determining a set where we send it only for the AI raters and only for the human raters. And now we take this set that below this confidence threshold where only the humans have rated, which we call the human set, we will provide it rater assistance. So first, looking at this human set, we see that the reason that hybridization helps here is that we found a slice where humans are outperforming the AI here. When we provide rater assistance to these humans, the components of the assistance we provide are these 4 components where we have first AI found directly, find some evidence directly quoted, then it provides some reasoning of this evidence, and then the final judgment. And then fourth, we also include the confidence mentioned previously. And so for our experiments here, we tested different subsets of this full output to determine which parts of this should we show to humans to achieve the best performance. And what we found is that if we only show directly quoted evidence, this significantly improves the accuracy compared to not using any rater assistance. But if we show the entire output or other subsets that include more prescriptive information, do not improve. Rater assistance does not improve accuracy on this human set. Small note is how we also tried a simple debate experiment where we showed this full output from on both sides, and this kind of rater assistance did not help. The models were not trained to do this, but it might indicate that better HCI research on displaying debate might be important for techniques like debate. Yeah, here we show that digging in a little bit more deeper into why just showing the evidence alone outperforms showing the full output of the AI, we can understand what's happening here with this concept called appropriate reliance, which we mentioned previously. The way we measure this is we first split our data based on the correctness of the final judgment. And that allows us to measure these 2 concepts called under-reliance and over-reliance. So under-reliance here is the headroom of accuracy when the AI is correct. So when the AI is correct, how often did the human rater not trust the AI? And that's under-relying on the AI. And you see this is like a little bit better with the full output, but more or less similar. And the over-reliance here refers to how much accuracy decreases when you show the AI assistant when the AI is incorrect. So when the AI is wrong, how much are you over-relying on the AI and therefore getting the answer wrong? And we see this is much bigger in the case where we show the full output, which might indicate that these human raters are over-relying or maybe sort of copying the output of AI assistant. And this sort of highlights a key issue with AI assistants where naive approaches might lead to this over-reliance and copying of the AI which makes it really hard to achieve complementary performance. Yeah, tying it all together, we show that hybridization, confidence-based hybridization, achieves higher accuracy than either human alone or AI alone, and enables complementarity statistically significantly. And on this human set, if we provide rater assistance, that helps in addition, also statistically significantly. And this is consistent with some of the learnings we described previously in HCI. And what we're really excited about future research, which could explore more sophisticated forms of hybridization, looking at human confidence in addition to AI confidence or other ways of slicing the data to find where AI raters are wrong, and also more sophisticated versions of AI assistants like interactive assistants.
Great. So we hope that, we've convinced you that at least currently humans still have a lot of complementary value, and finding a way to leverage the complementary strengths of AI and humans can lead to a higher quality oversight signal than relying on one or the other alone, which is exciting and promising. But there's still a question here of whether or not this will continue to be the case as we move into the future. So AI raters might not be the solution right now, but as AI models improve, AI raters will also improve. So will they be the kind of future solution of amplified oversight? And as we said, they're already surpassing non-expert human raters, but it's possible that they'll just continue to improve and potentially even surpass experts in certain domains. But we would argue that humans will still have complementary strengths to add. What exactly that complementarity is might change, but that there could still be value in leveraging both humans and AIs in this oversight process. In particular, humans are definitionally the source of human values, and values change over time. And so to ensure that our powerful and capable AI systems are aligned with human values, we actually need to verify somehow that they are aligned with what people want, and might need to update those value systems as human values change as well. And perhaps our kind of methods for eliciting human values are flawed and could be improved. But if humans are the source of their values, if we can improve those methods, then human labels, or at least incorporating human labels, should be more informative than just relying on AI. Also, human AI teams may be more robust to reward hacking, targeting the weaknesses of one or the other. So if kind of human biases or weaknesses and AI biases and weaknesses are not entirely overlapping, you could imagine that the human AI team could kind of counter these biases and be a stronger team, more robust team together. And there's actually already some interesting evidence of this. So from OpenAI, McCallis et al. 2024, they looked at AI assistants for detecting bugs in code. And they found that AIs tend to find more bugs in code than humans do, but humans hallucinate fewer bugs. And though the human AI kind of team didn't outperform either alone, it was more comprehensive than humans alone and less hallucinatory than AI alone, showing that it was able to effectively counter the biases of each. We know that AI systems have systematic biases, and these biases will persist. And again, only kind of relying on these could just cause these biases to become exacerbated. We would argue that how humans stay in the loop may change over time, but human input will remain important even as AI advances.
And finally, a note separate from amplified oversight is thinking a little bit about downstream user involvement. Beyond the training and evaluation of AI, the involvement of downstream users in decisions might still be important. And so when we think about having AI doing everything, this removes human agency and accountability. Agency might be important for our own well-being in and of itself, and accountability might be important as a lot of our society's contracts need to assign blame sometimes. And also this might lead to long-term cognitive de-skilling, as we've seen weak evidence of already. For example, in WALL-E, everything is automated for these humans and they forget how to pilot, and that might cause issues. Aiming for complementarity in the ways we describe here might enable downstream user involvement even beyond as AIs start to match or improve or beat humans alone in individual tasks. If we enable complementarity, we might be able to maintain downstream user involvement. Now, looking ahead, a lot of these learnings of exactly the complementary strengths of humans' AI might change. But this overall method of using hybridization to identify where AI raters are better and human raters are better should still last. And also, rater assistants should still help on this human slice. And also, using directly quoted evidence should still have lower over-reliance. And this can be applied to all sorts of different tasks. Looking ahead, we think we need more rigorous empirical research on how to achieve complementarity, specifically for amplified oversight in the context of human rating. But this will need cross-disciplinary collaborations with HCI communities, but also other disciplines in cognitive science, psychology, philosophy, and education, which we can learn a lot from.